Hey there, year 11s. In this example here, we're going to be looking at how to find the inverses of exponential and logarithms. So again, with this one, we know that from previous knowledge is that to find an inverse, we know that we'll be swapping, well, all the x's become the y's and all the y's become the x's. So here, the transformation that we're going to be working with. Okay, so transformation. What type of transformation? We are going from x, y coordinates will now become x becomes y and y becomes x. So we follow that sort of format. Well, then we know that f of x, let f of x equal to y. So now we can say we've got y is equal to 10 to the power of 2x. If we follow that transformation, then I probably should reorder it actually. Should probably be more like this. Maybe like that. Let f of x equal to y, and then I'm going to say transformation. This is your transformation, and that's your equation. And so, if we swap the x and the x becomes the y and the y becomes the x, well then now this becomes x is equal to 10 to the power of 2y. And our job is to rearrange it to find the value of y. Or not the value, sorry, the expression or the equation of y. And that's the inverse function of y, or the inverse equation for y. So here we go. We're going to now say to get rid of the base 10, that's an exponential base 10, then the inverse is logarithms. So I'm going to do log base 10 on the left hand side, and I'm also going to do the same to the right hand side because I'm doing the inverse, right? So log base 10 on the right hand side. Now the inverses of one another, so I know that log base 10 of 10 are going to cancel. Now, just to make it clear for you, I'm going to rewrite that step again. So log 10 of x is what I'm doing on the left, and I'm going to do log base 10 of 10 to the power of 2y on the right. And we know that these are inverses of one another, so they will cancel out. And so I end up with, on the right-hand side, 2y is equal to the log base 10 of x. Okay, and to get y by itself, divide both sides by 2. So I'm going to write here, divide this by 2 and divide this by 2. And this is what I get. It's half log base 10 of x. Okay? I'm just probably going to make more space by pressing enter. So that's what I want you to see there. So to finalize your answer, don't leave your answer there. Because it was in terms of f of x, we need to rewrite it all again. So the inverse function, inverse equation should then be f inverse is equal to, and remember we can't leave it as y because the original question was in f of x, that is half log base 10 of x. Okay, so that's how you would do it. Normally you're meant to write with the domain, but we haven't looked at domain yet. You're meant to write the domain, maps onto R, and then comma, and then you've got your function. But we haven't looked at the domain. Technically it should be R from memory, because that's a simple 10 to the power of 2x. So yeah, that would be your proper way of writing your inverse function. Okay, but I'm just going to leave it there. There we go. That's our first component. I took up a lot of space there, actually. Maybe I'll make it a bit bigger. We'll do that. Let's give it a bit more space. There we go. So we're going to do part B now. Let's do part B. Part B. Here we go. So we've got g of x. I'm going to let g of x equal to y. And then I'm going to say that this is a transformation. So we're going to do a inverse transformation. So inverse transformation, where I'm going from every xy coordinate now transforms to y x coordinate. So that makes this equation y equal to log base 10 of 2x now will become, which I probably, that's all right. The transformation would now become x is equal to log base 10 of 2 times y. Okay, and then here, same thing as before, we are trying to get rid of the log base 10 operation, and we know the inverse of log 10 is the exponential base 10. So that's what I'm going to do here. I'm going to do 10 to the power of the left-hand side and 10 to the power of the right-hand side. So I'm going to do here 10 to the power of the right-hand side. So if I write out what I'm actually doing, I'm actually saying 10 to the power of x on the left, and then 10 to the power of the right-hand side, which is log 10. 2y. See how I'm balancing the equation? And here we know that 10 to the power of log 10 are inverses of one another, and so they cancel out. And so we can then say 10 to the power of x is equal to 2y, and therefore y is equal to, by dividing 2 on both sides, I'm balancing the equation, and that now becomes half multiplied 10 to the power of x. Okay, so to finish off, my inverse equation will then be f inverse, oh, so it's not f, it's actually g. G inverse, just looks so bad there. G inverse is equal to half times 10 to the power of x. There you go. That's how you would do the inverse transformation there. Okay. Let's make this just a bit bigger. There we go, so we can suit it. Over here, find the rule for the inverse function of each of the following and state the domain of f inverse. Okay, so in each and every one of these, you should probably try to visualize what the graph would look like so that you can answer the domain and range. So here I would draw a very small axes here, and I'd say, well, logarithmic, what does this tell me? This tells me I've got a normal log graph, but there is a translation to the right by 2, meaning I'm moving to the right by 2. So that means I have a vertical asymptote. So this time with logarithms, unlike exponentials, you have a vertical asymptote. So there we go. That's my vertical asymptote at x equals 2. So I labeled my asymptote, and I know the shape of my graph will look something like this. Okay? Now, I don't need to find the x-intercept and y-intercept for now. Well, there is no y-intercept. I just simply needed to answer the domain and range question. So here, I know that the domain for f must be from 2, not inclusive because there's an asymptote at 2, all the way to infinity, positive. Okay? And then I know the range of f is clearly all real values. So that means when you find the inverse, remember the inverse, the domain of the inverse is equivalent to the range of the function. And likewise, you can then say that the domain of the function is equivalent to the range of the inverse. If you remember that from our previous chapters, I'm just going to write it here just to remind you. This is range of f inverse. Cool. So answering the question, we now need to find the inverse function. So here we go. I'm going to find the inverse function. So I'm going to say let f of x equal to y. And therefore, what's my equation? It's y equals to log base 2 of x minus 2. Transformation wise, I'm going to do xy becomes yx. So then I can then say here x is equal to log base 2 of x, y minus 2. And then from here, I'm going to do exponential base 2 on both sides to get rid of that log, because the opposite of log is exponential. So 10 to the power of x, and then 10 to the power of the right-hand side. So this now gives me 10 to the power of x is equal to 10 to the power, oh, not 10, sorry, what am I doing? Base 2. 2 to the power of x and 2 to the power of that on the right-hand side. So this gives me 2 to the power of x is equal to 2 to the power of log base 2 of y minus 2. Okay, and we know that these two are inverses, so you can then say in the next line y minus 2 is equal to 2 to the power of x. So 2 to the power of x plus 2 must equal to y. I'm running out of space, so I'm going to press enter a couple of times to move it down. Here we go. Let's move it down a bit just to give me a few more lines. So I'll write that again. this is now y is equal to 2 to the power of x plus 2. And remember, how did I get that? I did add two inverses of one another. Okay, and there you go. So for my final answer, that means the inverse function must be 2 to the power of x plus 2. Now, normally I would write it as actually you should do it as out of habit, because now we're working with the domain. So f inverse colon domain was r, maps onto r, and your inverse function is equal to 2 to the power of x plus 2. That's the proper way. Okay, so there you go. So that's what I would have done from the beginning. So let's do the same thing for b over here. If we were to do b, same thing. I would then say let f of x equal to y. So therefore, y is equal to 5 times 2 to the power of x plus 3. And due to the transformation, xy becomes yx. So this now changes the equation to x is equal to 5 times 2 to the power of y plus 3. Subtract 3 on both sides. So here I'm doing the inverse. Subtract 3 because that's a plus 3. So this now gives me x minus 3 is equal to 5 times 2 to the power of y. Divide both sides by 5 because that's times 5. So I'm dividing this by 5. And we know that these are inverses, so they'll cancel out. And so you're left with 2 to the power of y is equal to x minus 3 all over 5. And then finally, to get rid of the base 2, hopefully you're used to this idea now. Inverse of operation of exponential base 2 is logarithmic base 2. So I'm just going to move this to a side so they can fit the term log. So I'm going to do log base 2 on the left, and I'm going to do log base 2 on the right. Can you see how everything we've been doing, plus 3 becomes minus 3, times 5 becomes divide 5, and base 2 becomes log base 2. Okay, so I'm just doing the same thing, and that gives me now log base 2 of x minus 3 all over 5 is equal to, and these two cancel out. I'm just going to leave it there, just cancel out, and you get y. Yeah, I just want to leave the working solution so you can see what I'm doing there. And that is technically my inverse function there. So to do my inverse function, remember you need to know what the domain and range is. Now the domain of f inverse, so I'm going to write here domain of f inverse is equivalent to the range of the function. So going back, if you can visualize what this graph looks like, okay, so try to visualize what that graph should look like. I'm going to do it here just to help you out. Technically, you should just be able to look at the equation, but if we were to do it this way, what does the graph tell us? They tell us that it's moving up by 3, so that means asymptote moves up by 3, and that's about it. It's a normal exponential graph. So when you draw this, this is now horizontal asymptote. So up by 3. Here we go, y equals 3, and your normal exponential graph. There we go. Don't need to find the y-intercept. You just simply need to visualize what the range is. And clearly the range is from 3, not inclusive to positive infinity. Okay, so answering the question, that means f inverse colon, the domain is from 3 to infinity, maps onto R, and f of inverse x is equal to, and what do we calculate that to be? Log base 2 of x minus 3 over 5. Okay, I'm going to make that a bit smaller just so it fits. There you go. That is how you do inverse operations for both example 27 and 28.